What will be tomorrow? Every evening, as we prepare to rest, we ask this question to ourselves. It is perhaps the biggest mystery for all mankind. We can't help but wonder what the future has in store and worry about the uncertainties that may lie ahead. Everyone would like to look a couple of days or years ahead into the future and see what their life will be like. Will I be living the life of my dreams? Or is something really painful waiting to happen? Well, what's the worst that could happen to me? Death. Death shall ultimately claim us all. No one currently in recorded history has cheated death, and no matter how much we try to avoid it or delay it, death will come to us all eventually. Billions of years into the future, when the sun swallows the earth, or whether a cataclysmic event like an asteroid impact occurs, our existence will dissolve into minuscule atoms scattered throughout the vastness of space, moving haphazardly through the cosmic expanse. We'll return to the very particles that once birthed us. Essentially, we'll once again revert to a state of non-existence. However, the universe will continue its progression. The sun will still rise and set on countless planets. Seasons will change, and the tides will ebb and flow. Stars will be born, and planets will form, sustaining the ever-evolving web of life. The cosmos itself will continue to expand and evolve over time. All events unfold as they have in the past, with the exception that this time your physical form has transitioned, rendering you unaware of the transformation. Consequently, you may not perceive the alterations transpiring around you. Thus, when you cast your gaze upon the night sky, remember that the stars above may be composed of atoms that were once integral components of a living organism. Space is a synonym of possibilities. It is a realm where even the seemingly impossible can be possible. And there are moments when anomalies arise that are hard to explain in a universe governed by fixed mathematical forces. Just look at the night sky above you. Why do the stars, governed by these immutable mathematical forces, scatter themselves in a state of complete anarchy? Why don't stars repeat patterns in the universe? Could this unorderly arrangement be a cosmic message, one that has been overlooked and evaded humanity's attention throughout the ages? A carefully crafted message from an otherworldly intelligence. And what about the countless billions of stars that dot the infinite universe? How is it possible that we're surrounded by an infinite number of shining stars, and yet the sky remains dark? If the universe is truly eternal and infinite, and the stars are uniformly dispersed throughout the vastness of space, then in any direction we look at, we should see a star. The light from these stars, however distant, would eventually reach our planet. Since time immemorial, every human inquisitive in nature has thought of these questions at least once. With the advancements and availability of state-of-the-art space tools at our disposal, we find ourselves closer than ever to unlocking the mysteries that have eluded us for ages. It's time to peel back the layers of enigma that obscure our understanding of the cosmos and cast a light upon these captivating mysteries of the universe. Take a close look at this picture. This is Eugene Cernan, seen here saluting the flag of the United States. The last person from the Apollo program to set foot on the surface of the moon. However, upon closer examination, you might notice something quite peculiar. There's not a single star to be seen in the background. In fact, every photo taken on the moon during the famous Apollo missions exhibits a sky devoid of stars, despite the fact that the universe is packed with countless sparkling celestial bodies. Even the Apollo astronauts themselves confirmed that they couldn't discern a single star in the lunar sky. This mystery has sparked all sorts of debates and conspiracy theories over the years, with some even using the absence of stars as supposed proof that the moon landing was a hoax. However, the explanation for this mystery delves far deeper than any conspiracy theory. In fact, the resolution to this cosmic puzzle once again leads us to a profound cosmic truth: the Big Bang. Why is space so black? The idea behind this query was first introduced by Johannes Kepler in 1610. Our Milky Way galaxy alone contains anywhere from 100 to 400 billion stars, and the observable universe contains roughly 100 to 200 billion galaxies. By this notion, astronomers wondered that since the universe is filled with a seemingly endless number of luminous, light-emitting objects in all directions, logically every patch of sky you choose to look at should contain thousands, if not hundreds of thousands of stars. This should cause the night sky to be uniformly bright in all directions. Careful analysis suggests that the sky should be as bright as the surface of the sun. This is not the case, however, which puzzled astronomers. It is a paradox that took nearly 300 years to resolve. The paradox had emerged from the steady-state theory, which was the most widely accepted viewpoint on the universe at the time. The steady-state theory said that the universe has been and always will be like it is today. And moreover, that the universe was infinite in size, had no beginning, and was uniform in all directions and did not expand. Initial attempts to resolve this paradox involved speculating that most of the stars were simply too far away to be seen. However, this explanation was quickly dismissed, as the steady-state theory itself posited that the universe had existed infinitely long, thus allowing light from even the most distant stars to reach us and contribute to a bright sky. Johannes Kepler came up with a different solution to the paradox by challenging the steady-state theory. Kepler suggested that the stars in the universe extended only to a finite distance, beyond which the viewer encountered only empty space. While this idea seemed plausible, of course, this solution prompted the questions: how far away is the boundary? And what lies beyond it? Additionally, the notion of a finite universe posed challenges, such as it would eventually collapse in on itself under the gravitational pull of its stars and planets. This led most astronomers to continue to assume that the universe was infinite, and thus the paradox and the steady-state theory remained as is, unresolved and forgotten. Until after nearly 2 centuries, when Heinrich Wilhelm Olbers, a renowned German astronomer, breathed new life into the paradox and once again asked the question, why is the night sky dark? Since then, Olbers' name has been closely associated with the paradox. Once again, the common belief during his time was that the universe was static, infinitely old, and infinite in size. This time, Olbers had a simple solution. If we assume that the universe is infinite, it is logical to deduce that the opaque bodies in it would also be infinite in number, such as dust and rock that obstruct the light from distant stars, making them appear fainter. The cosmic dust gradually absorbs and blocks the light of stars as it journeys through space. Even today, most people subscribe to this theory, drawing parallels between it and the way clouds obstruct the sun's light and view. Cosmic rocks and dust likewise could eclipse light from stars. However, Olbers' compelling solution still does not entirely solve the problem, as any rock or dust would eventually heat up and radiate the absorbed energy. The universe would still contain the same amount of radiation. The dust merely acts as a mediator, so to speak, between the stars and the observer. Ultimately, the energy we detect on Earth would be the same. So, what's the solution to the paradox? The solution to the paradox would be revealed after a wait of another 100 years. In 1929, when Edwin Hubble peered through his powerful telescope, he hoped for a universe that would be collapsing, as that would prove a finite universe, just like Kepler said. But to his shock, he discovered that the universe was not collapsing in on itself, but rather the galaxies were moving away from us, as if the space between was expanding. In fact, the further away the galaxy, the faster it was moving away. The universe appears to not be falling in on itself, not remaining static, but expanding. This raised a new question. If the universe is expanding, then what does that mean for the early universe? Cosmologists now believe that the universe was once incredibly small and dense, and that it expanded rapidly in a phenomenon known as cosmic inflation. Background: the farthest point in the universe that we can observe from Earth. When we point our telescopes past the earliest stars, we see this light. This is not starlight, but the light left over from the Big Bang, forming a background beyond the stars. But wait, the Big Bang theory seems to introduce a new problem. It states that the universe was much brighter in the past, especially at the end of the recombination era. All points of the local sky at that era were comparable in brightness to the surface of the sun, due to the high temperature of the universe in that era. So the cosmic microwave background should actually be dominating our night skies back on Earth, resulting in a constant need to wear sunglasses all the time to avoid being blinded by the intense brightness of the universe. Thankfully, this is again offset by the fact that the universe is expanding, and the expansion hasn't stopped after the Big Bang. Instead, it has only gotten faster, meaning new space is constantly being created even faster than the speed of light itself. At first sight, this may seem the violation of the principle of special relativity, which states that nothing can move through space faster than the speed of light.